This is a Jamb past question I saw and I decided to solve it for you guys. The oxidation state of manganese in KMnO4 is what? So I'm going to solve this. If you find this video helpful, do follow me or subscribe to my YouTube channel. So let's go, guys. So the first thing is to know the oxidation number of potassium, which is K, manganese, which is Mn, and oxygen, which is O. So now, normally, when they just say the oxidation number of potassium is +1 and oxidation number of oxygen is -2 in most cases. But let me explain why the oxidation number of potassium here is +1 and that of oxygen is -2. Most times that is the result. So now we all know that potassium has an atomic number of 19. That means that it has 19 electrons. And we know that valency is just like the combining power of elements. So here we know that signs in chemistry, let us say the positive sign means an atom wanting to lose electron. If they say something is positively charged, let me say +1, that means it wants to lose 1 electron. If you see something like -1, that means that it wants to gain 1 electron. That is chemistry for you. So let me explain why the oxidation state of potassium is usually +1. It has 19 electrons. So let us draw the diagrammatic electronic configuration. I usually love doing this because I feel it is very simple for people to understand rather than using the complex one. In my next video, I'll be explaining how to actually write good electronic configuration using the SPDF formula. Okay, so let us go. Here it has 1, 2, 3, 4, 5, 6, 7, 8. This is making it 18. It also has another shell with just 1 electron. So it shows that potassium is ready to lose just 1 electron. If it wants to bond with any type of atom, it will always be an electrovalent bond because it is quick to release. That means that it is positively charged. So that is why the charge is +1. For oxygen has an atomic number of 8. And this is just the configuration. It has, let me see, 6. Yes. So it's waiting to receive 2. Oxygen is waiting to gain 2 so as to have the octet structure. So as to attain octet. So as to get to the octet structure. So that is why the oxidation state of oxygen is usually -2. But in some cases it is -1 that is usually in peroxides. So now let us continue with the solving. Let us go. So before I start solving, there is a particular law that states that the sum of the total oxidation numbers of a neutral compound is 0. And this is how you can know a neutral compound. A neutral compound is a compound that does not have a charge. You can see this compound does not have a charge at all. Does not have either a positive charge or a negative charge at the top. So any charge or a radical that has a charge, the oxidation number or the sum of the total oxidation number is usually the charge. I'm going to explain this in a different video. But for this video, any compound that is neutral, any compound that does not have any charge at the top, it is always a neutral compound. And the sum of the total oxidation numbers is 0. So now let us start, or let us continue with what we are doing. So now we need to write down the elements one by one. K plus Mn plus O4 is equal to what? 0. So the sum of the oxidation numbers will be equal to 0. So now what is the oxidation number of potassium? +1. Write it there. Plus what is the oxidation number of manganese? That is what we are looking for. We don't know it. So let us just represent it with X. So now for oxygen, you can see that oxygen actually has a subscript. So we have to multiply the oxidation number of oxygen with the subscript. You see, these ones also have subscripts, but their subscript is just 1. That is why I just wrote it directly. So now for oxygen, we are going to write 4 multiply, this is the subscript. Use the subscript to multiply the oxidation number. -2 is equal to 0. So now let us continue. This will give us 1. Let us just put this as 1 plus x. Then 4 multiplied by -2, that will give us -8 equals 0. So now let us just add this. 1 minus 8 will give us what? -7. X minus 7 equals 0. So here we can just do add 7 to both sides, or just correct like terms by carrying 7 to the other side, which will be equal to x is equal to plus 7. So the oxidation state of manganese in this particular section, in this particular compound, is plus 7. So that is that for that. So let us move to the second question. Here it says the oxidation state of chromium in K2Cr2O7. So this is actually the same thing, having the same atoms or the same elements. So I feel that should be simple for you. But let me just do this quickly. Using the same method, we have K2. You can see this is having 2 plus Cr2 plus O7 equals 0. Why is it 0? Because it is a neutral compound. Don't forget that. So now let us continue. You can see here potassium actually has a subscript of 2. So now we multiply the oxidation number of potassium with the subscript. So the subscript is 2 and the oxidation state of potassium is +1. Why? I have explained that before. Don't forget. Plus, we do the same for this. But we don't know chromium. We don't know the oxidation state of chromium. So we just write or represent it with X or any number that you like, or sorry, any alphabet that you like. Plus this is the subscript is 7. We multiply it with the oxidation state, which is -2 equals 0. So now let us continue. 2 times 1 will give you 2, plus 2 times x will give you 2x, plus plus, let me just do it at once. 7 times -2 will give you -14. -14 equals 0. So now we have 2 minus 14. That will give you 2x. 2 minus 14 is -12. Will give you -12 equals 0. So you just add 12 to both sides, or you collect like terms by taking 12 to the other side or to the right hand side. So 2x will be equal to 12. And then you divide both sides by 2. We divide both sides by 2, which will give you, so x here will be equal to plus 6. So now the oxidation state of, sorry, I was writing M instead of Cr, which is chromium, of chromium here in this compound is plus 6. So I believe this is very simple for you to understand. If you don't understand this, then you can just let me know in the comments. Do well to subscribe to my channel and follow me for more chemistry tips like this.